Hi Matrix, welcome again. We are carrying on with our memo from the 29 paper 1, the NSC. We did question 4 last time, which was a functions question where we looked at a parabola and a hyperbola. This week we've got question 5, which is an exponent graph, an exponential graph. So we're given the y-intercept as 1, and we are given another point on the graph. And 5.1, they ask us to calculate the value of k. So we can just write in f of x equals k to the x. And we can just substitute in the point because we have our f of x, which is the same as saying y. So we know that y is 16. K is what we want to find, and x is equal to 4. Well, we know that 16 is 2 to the power of 4. And so we know that therefore k is equal to 2. So that's a fairly simple question to begin with. 5.2 says graph G is obtained by reflecting f about the line y equals x. Determine the equation G in the form of y equals. Okay, so when you change about the line y equals x, basically what that means is y is now x and x is now y. So what I'm going to do is I'm going to write this down as y equals k to the x instead of f of x, and then I'm just going to swap. So where I see a y, I'm going to write an x, and then when I see an x, I'm going to write y. Okay, we found out from the first thing that k was equal to 2. Okay, now they want it in the form of y equals. So I need to swap. Now I have y as an exponent, and there I need to use logs. So when you do use logs, just remember this: log base number. Let me do that in a different color. Log base number equals exponent. Let's write that. Log base number. If you already know about logs, you can skip to 5.3, just skip ahead. But for those of you who don't know logs, I'm just stopping here. Log base number equals the exponent, just to go over that, because I know a lot of students do battle with logs, and it's actually not too bad. So just remember the line, log base number equals exponent. Log base number equals exponent. Say it over and over and over so that you know. Log base number equals exponent. And then you use this because what is the base? The base is always something that, if we think of it, the base of a tree, it's at the bottom. And a tree has leaves at the top. So you would think of, it's got something at the top, and that is an exponent. The exponent is the thing at the top. And number refers to the number on its own. And now we can use that to convert this here to logs. So I'm going to write log base, log base. So base is the thing that has an exponent. The base is 2. The number is the thing by itself, which is x, and that is equal to our exponent y. Okay, log base number equals exponent. So that is in the form of y equals. I can just write it the other way around because that's how they want it, log 2 to the x. Okay, log base number equals exponent. So when you're thinking of logs, just remember that Log base number equals exponent. I've said it a lot of times, and hopefully you'll remember. Okay, 5.3 says, sketch the graph of G and indicate on your graph the coordinates of 2 points on G. Okay, so we swapped X and Y. So let's look at what happened. This point here was 0 and 1. So we swapped X and Y. So we're actually looking for the point where X is 1 and Y is 0. And that's here. And because we swapped X and Y, you also have a point 4 and 16, you'll end up having a point 16 and 4. So we find the point where X is 16 and Y is 4. Okay, it's going to be here somewhere. Okay. What I want to also talk about is just the exponential graph quickly. Okay, so if we have an exponential graph, okay, the standard exponential graph looks like this: y equals a to the x, and that point, it always intercepts at the point 1 unless it's shifted up or downwards, because anything to the power of 0 is 1. So we know an exponential graph has an asymptote of y equals 0. And that's what we have here. So when we change y and x, or when you reflect about the line y equals x, swap x and y, it just means the same thing. The inverse is another way of putting it. You also change the asymptotes. So if the asymptote before was y equals to 0, if you swapped x and y, you're going to have an asymptote x equals 0 of our new graph, our new function. So we have in blue, I'm going to put the points. So we had this 1 intercept. And we know this is going to be a point there. Okay, so we can already see probably what's going to happen. We're going to have a line that's approaching x equals 0, but never touching. And it's going to go up like that. Okay, and that is g of x. Okay, now in your exam, you're going to have an answer sheet, so you draw it on there. And they want at least 2 points. Well, we know the 2 points we've got are 1 and 0 and 16 and 4, because we swapped x and y. Okay, so that was 5.3 done. Okay, now 5.4 says, use your graph to determine the values for where f of x times g of x is greater than 0. What is that? What is another way of saying that? You could say, for that, if we say f of x times g of x is greater than 0, what are we saying? We're saying that it's positive. Okay. So if something is positive, it means that the signs of those two things must be the same. So like if I say -2 times -2, I get +4. If I say 4 times 4, I get +4. If I say -2 times -2 times +2, I get a negative. So basically what I'm saying is the signs have to be the same. So this either has to be plus and plus. Okay, so I'm going to draw the or, minus and minus. Okay, so let's look at these graphs. Well, over here, and I'm going to do this in yellow. Over here, the graph of g of x is not even there. So you're not going to get a value. Over here, you have, so in yellow, there's obviously, that's not going to be one of the answers. From here to here, where I've done it in purple, you see that this graph here is positive, 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 because it's up above the line. In fact, this is always positive, as we can see. Yeah, always positive. Okay. And the other graph is positive over here, but at this point here becomes negative. At between 0 and 1. So where are they both positive? Well, we can just draw a line there. I'll do it in. So yellow will be where it isn't true. And then it's true from this way all the way up here. Okay. So from here onwards, we see that they're both positive. So they want the values of x for where that's true. So the values of x, well, x here is greater than 1. So we'll say x is greater than 1, but it's less than infinity. Or you can say, another way of saying it is x is an element of from 1 to infinity, and you can write that either way. If it had been greater than or equal to, you would have had a greater than and equal to sign here, and this would have been a square bracket. Okay, now they want to know, where is g of x greater than and equal to -1? Okay, g of x greater than or equal to -1. Well, we need to just figure out the point, because y is -1 around about, yeah, okay. So the values of x on this way. So what we have to do is we simply have to substitute in y over here. So let's do that. Our graph of g of x was y. Okay, so this was 5.4.1. 5.4.2. Okay, so the graph of g of x is y equals log 2 to the x, and they're saying when y is less than -1. Well, let's see the critical value. So we'll make y equal to -1. X. Okay, so we're going to use our exponents here to get x by itself. Remember, log base number equals the exponent. Log base. So the base is 2. The number is x, that's the number by itself. And the exponent is -1. Okay, log base number equals exponent. So x is equal to 1/2. That makes sense. So if I just running out of colors here, it's looking like a bit of a mess. But if I follow this from this purple point up, I see that it's a half. And so where is x less than a half, less than -1, it's going to be, I'm going to do this in dark brown so that you can see, it's going to be all of this point here. But what do we know? We know that there's an asymptote of x equals 0. So it never comes across this x equals 0 line. So it's between 0 and a half. So that was the critical value. So finally, I'm going to say in the middle, put x in the middle, 0 here, and a half here. So x is greater than 0, but not equal to 0 because it's an asymptote, it never touches. And so, but it's greater than, it's less than and equal to a half. Okay, last question on this is 5.5. It says h of x equals f to the minus x. Calculate the value of x for which f of x minus h of x is equal to 15/4. Okay, so the first thing they've said is h of x equals f to the minus x. So what does that mean? That just means if f of x is equal to, we got f of x to be, k was 2, right? 2 to the x. Then f to the minus x is going to be 2 to the minus x, right? I'll just do that in color, just so that we can see. So we see where f of x, the x is yellow, okay? And so if it's minus x, we just simply change that x to a minus x. And so that's the graph of f to the negative x. So that's what h of x is. So h of x is this. So this is, now we know h of x, because h of x equals f to the minus x. Well, we know f of x and we know h of x now. And so they've said, what is f of x minus h of x? And when is it equal to 15/4? So we know what f of x is, so we're going to substitute that in. So that's 2 to the x. And we know h of x is 2 to the minus x. And that's equal to 15/4. So now what we have to do is we have 2 to the x and a half to the x. Now the problem here is that we don't have the same basis. So we can't, there's nothing we can do with these x's. We can't add or subtract them because it's not multiplying. But what we can do is we can just look at our graph and we can see what f of x might look like, or f to the minus x. So what we know is that when we change it from x to minus x, we flip it about the y-axis. So if our x was positive 4, on this side it's going to be then negative 4 and 60. And so it's going to be reflected about the y-axis like this. Okay. So the pink line is f to the minus x, or h of x. Now, we're saying where f of x, the black line, the original graph, minus the pink graph, is equal to 15 over 4, which is, if we put it in our calculator, is 3,75. Well, if we look at this point 4 to the y-axis, that distance there is 4. And we know the distance is supposed to be less than 4. So what I'm talking about is this distance here is less than 4. This distance here is 0. Well, that makes sense, because if we substitute 0 for x, we get 2 to the 0, which is 1, and a half to the 0, which is also 1, and 1 minus 1 is 0. So that's why we get a distance of 1. So we know that it's in between these 2 points. We know that it's in between these 2 points. But here's the trick. We see that it's 15 over 4, which means that it's probably going to be a number which is also going to be something over 4. Well, this half to the x here, there's only one integer that is going to make this value for x, that's going to make this value something over 4. Because if we use 1, 2 to the 1 minus a half is 1.5, which is 3 over 2. But what if we put in 4 for x? Well, if we put in 4 for x, we get a quarter, because a half to the power of 2 is equal to a quarter. And 2 to the power of 2 is 4. So we know the answer is x equals 2. So we just leave that in there, and we say 2 to the power of 2 minus a half, a half to the power of 2 is equal to 3/4. So because of the graph, we were able to see that it was in between these numbers, and because it was 15 over 4, it had to be, this half had to be something over 4, because we got a whole number. So the half had to become a quarter, and we did that by making x equals 2, and it just worked out quite nicely. It's very difficult to do it any other way, because the method of having a basis subtracted from each other with different exponents is not something that we've done in the Matric syllabus. So we just finish off by saying, therefore, x equals 2. There's not 2 answers, because over here at x equals minus 2, let's change that. At this point here, x equals minus 2, when you subtract them from each other, the pink line is above the black line. So if we were to do 2 to the minus 2 minus 2 to the minus 2, we would get minus 15 over 4, because these are exact symmetries of each other. So once again, 5.5, they always put in a little tricky question at the end. But hopefully you should have got the first 4 fairly easily. If not, then just keep studying and keep checking in for more videos. I'm going to be finishing the rest of this memo, and I'm going to be putting some more video memos online as well. So yeah, please like and subscribe so that you can get notifications.